Sometimes binomial theorem questions will ask you for a specific term. So they'll tell you the position of the term and they want you to find that specific value. So you might think, oh, I'll just expand, use the binomial theorem, but sometimes expanding will just take too long and you're losing too many marks on unrequired work. So we want to devise a method to find a specific term without having to go through the whole binomial expansion. So when that happens, you'll want to use this main part of the theorem, the binomial theorem, which is that the first part of your term is always the NCR. The second part is taking the first term to the power of n minus r, and the third part is taking the second term to be to the power of r. So we want to use this fact. It seems a bit odd how we're going to use it, but you're going to see with a lot of examples that it's going to be quite easy. So let's say we have this. Find the seventh term in the expansion of 3x minus 4y to the power of 10. So notice how it's to the power of 10. If you spend expanding it, it's just going to take too long. So we want to use the clue of the seventh term. So first let's write it out. So we're going to use this theorem and we're going to write it out. So basically we mainly want the term is always going to have the first part as 10 to the power of r. We don't know what r is. We just know that n will always be 10. We know that the first term, which is 3x, will always have a 10 to the power of minus r. And the second term will always be negative 4y to the power of r. So this will always happen no matter which term it is. We just need to figure out which r it is. So go back to the binomial theorem, read through it, and try to remember that this is always the same thing for every term. So we're just going to write one of it, and we want to decide which r fits this seventh term. Well, something that's quite useful is this expression or equation, is that to find r, you're going to take the term number minus 1. So that's always useful. And you can kind of go back and reflect on the statement, why does that happen? Something to note is that sometimes when you have, when we're expanding to the power of 10, you will always end up with 11 terms in total. If I'm expanding to the power of 4, I'll end up with 5 terms in total. If you're expanding to the power of 2, which is something simple you've done 8 years ago, expanding something to the power of 2 will always give you 3 terms. So this is something to note as well here. So we have we are going to use this term number equation. So r is going to be equal to the term number. We want the seventh term, and 7 minus 1, so that's equal to 6. Be careful, questions that ask for the term position rather than a variable. There's another video dealing with a specific variable that they're requesting. In this case, they're giving you an expression of the term. So they want the seventh term, so 7 minus 1, so that's going to be equal to 6. It means that the r is equal to 6. So I'm just going to use this and substitute 6 in there. Well, you can actually solve this quite easily. We're going to solve the first part and then expand the second part. This 10 minus 6 is going to be to the power of 4, and I can give the 6 as well to each one. So again, we found the 6 using this formula that r is equal to the term number you want. So they always give you the specific one, minus 1. So simplifying this, 10 choose 6 will give us 210. This will simplify to a 4, so 3 to the power of 4 and x to the power of 4. Remember, you have to spread the power. And again, spread the power here, negative 4 to the power of 6 and y to the power of 6. I'm going to collect the coefficients together. So take the numbers together and then simplify it again, and that's going to give me this big number. So notice how it was a much quicker process than actually going through the whole expanding to 10 terms. Let's try a different type of example. So this time they're telling you what the fifth term is. So the fifth term of this given expansion is 560 x to the power of 3 y to the power of 4. Find the values of a and b given that they are integers. So this is a bit different. They are telling you what the outcome is. The exception is that you don't know what the inside terms are. But let's, again, whenever you're stuck with these, always go back to the equation that we're going to keep on using this binomial theorem term. So we're just going to write what we have. We don't even have the n here, but we know n choose r. The first term is a to the x to the power of n minus r. The second term is b y to the power of r. So that's as much as we know. So we also know they want the fifth term. So we're going to take 5 minus 1, so that's going to be 4. So we know our r is going to be 4. So let's just substitute. Instead of r, we're going to put 4. Here, this is going to be 4. This is going to be 4. Now we know that this is equal to, let's say you're stuck. Go back to the question. You're like, okay, I know that the fifth term, I found the fifth term, r is going to be 4, is 560 x to the power of 3, y to the power of 4. So I know that this thing that I'm trying to find should be equal to 560 x to the power of 3, y to the power of 4. So they should be equal. Now I should use some property. Pause the video, take a few seconds to look at it and see what you can deduce from here. So one thing you would notice, y is to the power of 4 and y is to the power of 4. It means, okay, you're sorted with the r, that's great. Well, let's look at the x. I have x to the power of n minus 4 and x to the power of 3. It means I can use these in order to find n, because I can't move on unless I found n at the moment. This is kind of what I'm missing. So if I can find n, that would be great. If I can find as much information as possible so that the only unknowns left are a and b, that would be good. So I know n minus 4 should be equal to 3 because the x has to be to the power of 3. This means that my n is equal to 7. So that's amazing. I can put in my 7 choose 4, ax to the power of 7 minus 4, by to the power of 4, 560, and so on. So this simplifies to the following. 7 minus 4 is 3. 7 choose 4 will be 35, a to the power of 3, x to the power of 3, b to the power of 4, y to the power of 4. This should be equal to 560. Now, let's bring it here. Okay, so we have it all together. Do you care about the x and y? Not really. You just want to deal with the a and the b. So actually, I can cancel out the x. I have x to the power of 3 on this side, x to the power of 3 on the other side. Same thing here. Now, you could have skipped all of this and done it quite quickly, but I did want to go through a few more details. So you're left with this, and again, I could divide by 35 on both sides, so I'm left with 16, so quite a small number. So how do we go about from that? So something to note is that they told us a and b are integers. It means that they're whole numbers, negative or positive. So either they're both negative whole numbers or they're both positive whole numbers, but be careful. If a was a negative whole number, then cubing it will remain negative and b will be positive, so it won't work. You can spend a bit of time kind of testing out numbers to see, but eventually you'll conclude that they both have to be positive numbers. Now, how do you go from there? You can do a bit of a trial and error, but something to see is, well, let's just test out a few numbers. One thing that I like to do is memorize powers of smaller numbers, like 2 and 3. Maybe a bit of 4, mainly 2 and 3. So if you notice, 2 to the power of 4 is 16. So if I actually write 2 here instead of b, and that could be to the power of 4, and that will give me 16, which means that a just has to be 1. Sorry, a has to be 1. So that works. That works. If a is equal to 1 and b is 2, then this would work. Because the 16 comes from something raised to powers as well, so we need to be careful. Well, let's test out another number. 2 to the power of 3, maybe this would work here. 2 to the power of 3 is 8, so if I put 2, that would be 3, that would be 8, but then I need to multiply by a 2 here. So I need to multiply it by something that would be equal to a 2 to give me a 16, and there's no number raised to the power of 4 that will give me a 2. So what I need is a 2, but do I have something raised to the power of 4 that would give me a 2, given that it has to be an integer? So b has to be an integer, and there's no such number. There's no such integer that you raise to the power of 4 and it will give you a 2. So that means that by trial and error, a few understanding of numbers as well, like actually understanding how these powers of numbers would work, a would be equal to 1, b would be equal to 2. That is your best choice. In here, as I said, a could be equal to 2, but what could b be? There's no other option. So there's no other option for other numbers that you could test, so you can just, this would be your final answer, and we can therefore simplify the bracket into a being 1, b being 2, and that would be the expansion to the power of 7. You can test it out by expanding it again and finding the fifth term and saying that would give you 560.